Chapter 9, Key Issue 3 is about energy. So why is energy important for development? And so we're going to get into renewable and non-renewable energy in this section, which is probably a great review for those of you who took AP Environmental already. And for those of you who will be in AP Environmental this spring, we are going to kind of just review it when we get to that class. So this is going to give you a great introduction to stuff you need to know for AP Environmental. Keep in mind that you've learned about renewable energy, I'm sure of it, either in a science class or a social studies class in middle school, hopefully maybe a little bit in high school too, but you're going to need to know more details than just renewable is gone, non-renewable can be reused, more than just like wind power is renewable, oil is non-renewable. You need to know a little bit more details. So even though it seems like an easy topic, there's a lot of stuff to learn about it. So where do we get, why do we need fossil fuels? Where does that demand come from? What's the distribution of the three fossil fuels? Where do we find them the most? And how does that correlate to a country's wealth and political power, really? What's the difference between proven and potential resources? What is OPEC? What does it mean? How do they control prices? Describe the distribution of nuclear energy. What are challenges with it? What are the challenges to using more alternative energy? And what's the difference between passive and active solar energy? So energy demand and supply. Supply is the quantity of something that is available. So how much do you have? And demand is how much do people want? It's the amount that people are willing to buy. And so the greater the demand for something, usually the higher the price. And if you have a limited supply, that means you can raise the price even more. So supply and demand dictate why we use fossil fuels for energy. It's what people, even if individuals want more renewable energy, most of our governments, most of our cities, most of our infrastructure, most of our industry is built up around fossil fuel use, which means our demand is high and our supply is limited. Even though there are people who say that it isn't, which is bizarre, because it really is just a non-renewable resource. Supply is limited, demand is high, so the prices will be high. 5/6 of the world's energy needs are supplied by fossil fuels. Fossil fuels come from the residue of plants and microscopic organisms called diatoms. Not really from animals. Plants and produce buried millions of years ago. 27.9% of the world uses coal for most of its energy. Petroleum is about 33%, and natural gas is about 22%. These numbers might be a couple years old, but they're still within these ranges. So we use oil more than anything else. Keep in mind that petroleum is used for more than just gasoline in cars. It's used for like diesel fuel. It's used in plastic. It's used in asphalt and like the stuff they put down on the road when they're paving the roads. Yeah, so we use petroleum for many things. Although we have far less highly developed countries, we consume about half of the world's energy. So if you look at China alone uses about 20% of the world's energy. The U.S. uses 18% of the world's energy, and the entire region of Europe uses 15%. So our country uses more energy than all of the countries in Europe together. And we have a big country, so part of it makes sense. Like the United States is a large country, China is a large country, Russia is a large country, India is a large country, and China, U.S., India, we are large countries with large populations. So it makes sense that we use a lot of the energy. But we don't have 18% of the people or 18% of the land mass in the world. So we're using more than would be predicted based on our population size. The per capita energy consumption is greatest in North America. So North America has 1/20 of the world's population. And in North America is the entire continent, right? But we use 1/4 of the world's energy in the U.S., Canada, and Mexico. The per capita consumption of energy is 3 times greater in developed countries than developing countries. So in highly developed countries, we use more electricity. And at this point, we do have better infrastructure in place. But keep in mind that we're talking about developing countries while there are some very rural areas, there's areas without farming, the road. Like, we're not talking about like a whole state that's filled up with just hunters and gatherers, right? Like, these are places with cars and cell phones, and so think about how hard it would be for you to move through like the stages of development and to improve your quality of life if you don't have access to energy. And if we're using a quarter of it, and these highly developed, if we're using a quarter of it in North America alone, like, how are you going to be able to access that energy? Because there is a limited supply. So if you look at this map here, you're looking at the millions of BTUs of energy consumption per capita. BTU stands for British Thermal Unit, and it's just a measurement of energy. It's easier to measure large quantities of energy in BTUs than like kilowatts. So you can see Canada, the US, most of Europe, a couple of places in North Africa, South Africa, Australia. But in general, it kind of fits our trend. Like, these are the places you would expect to have high energy usage. As far as energy supply, we don't use energy evenly, but it's not distributed equally. So if you look at the global distribution of coal, most of the coal reserves are located in the mid-latitude countries. So in China and the US, we supply nearly half of the world's coal, about a quarter of it each. So even though coal, like we're starting to use less coal in the United States, we've been using more natural gas, we can still export coal. We have 1/4 of the world's coal reserves in our nation, and so even if we move on to using less fossil fuels here, we could still export it for a while as other countries convert to renewable energy. So there's many ways we could be leaders in the renewable energy movement while still transitioning and still making these processes financially viable. As far as the global petroleum distribution, most of the reserves today are located on the seafloor, and they're in areas that were underwater millions of years ago. Because oil is going to be made from diatoms and microscopic algae, and so it's going to be places that were covered in water. And it's microscopic algae that was under heat and pressure for millions of years. Coal is the remains of plants so you'll find coal in areas that weren't underwater millions of years ago. Russia and Saudi Arabia together have about 1/4 of the world's petroleum supply. And we have about a quarter of the global supply. So the remaining half of the world's supply is supplied by developing countries in Southwest Asia, Central Asia, and some areas in Sub-Saharan Africa, but like the northern part of Sub-Saharan Africa. So we control a lot of oil, and I think that we kind of forget that we are a very oil-wealthy country, and yet we still practice, I think, global politics based on making sure we have access to enough oil, but we have a lot of it. We use a quarter of the world's energy, but we have a quarter of the world's coal and a quarter of the world's oil. So I think that maybe we could dictate our foreign policy on more than just oil. So if you look at coal production, again, we're in the highest rates for coal production, us in China. We are in the highest for petroleum production. As far as global natural gas production, 1/3 is supplied by Russia and Southwest Asia, another third by developing regions, and the last third by the developed countries, but mostly the US. We have lots of natural gas too. So we are a country that uses a lot of energy, but we are rich in fossil fuels. And so we really have the potential to be energy independent already. When we look at the supply of energy, we have two types. We have proven reserves and potential reserves. Proven reserves are the supplies of energy that remain in deposits that have been discovered. So proven reserves, like, we know they're there. And potential reserves are as energy that we think is undiscovered, but we think it'll be there based on information about its geological status, based on like satellite imaging. So like if we know that there's lots of pockets of rock, sometimes we can predict that there would be oil or natural gas in it. If we look at what we can use, the proven reserves of fossil fuels at our current demand levels, we have enough coal for about 130 years. We have enough natural gas for about 49 more years, and enough petroleum for 43 more years. And this book is recent enough to have included new technology like hydraulic fracturing to get oil. And we'll go into what that is in class. Here you can just see the breakdown of coal in developed and less developed countries. Potential reviews are classified as a proven resource. So undiscovered fields are areas that are smaller and more remote, but they have the most accessible fossil fuel deposits that have already been removed, but maybe we could get some more from there if we had to. Enhanced recovery from already discovered fields. This again is when we're going back and we're kind of, there was coal there was natural gas there, but it was too deep for us to extract, but now we can extract it because now we have new techniques like improved hydraulic fracturing. When I say improved, I mean the technology is improved. Hydraulic fracturing is usually pretty terrible for the environment. Or you can use unconventional sources. So maybe there's oil or natural gas or coal there, but we can't get to it now. But maybe eventually it would be either economically feasible, or maybe the pros might outweigh the cons of removing it. So like there might be coal in areas where they won't practice mountaintop removal, which is where you're literally blowing up the top of a mountain to get more coal. And so in most places they won't allow that. But, you know, if we were running out of coal, like in 100 years, maybe then people would be willing to do that. How do we control petroleum reserves? There is an organization called OPEC. It was formed in 1960. It's called the Organization of the Petroleum Exporting Countries. In 1960, OPEC countries wanted to gain control over their resources. Prior to the 1960s, the U.S. and European transnational companies were exploring and exploiting the oil fields of developing countries. So places like Algeria, Iraq, Kuwait, Libya, Qatar, Saudi Arabia, and the United Arab Emirates, and then also Angola, Ecuador, Iran, Nigeria, and Venezuela. Many of these areas were being exploited by colonial powers, right? So we're back to that colonial legacy. So they had Europeans in their country still controlling the oil fields while these countries were sometimes being given independence. So they formed this organization so they could set the price for the oil rather than the oil companies. This allowed them to kind of control how much of their supply they were giving out. So if they felt like they were running low on their own reserves, they could raise the price and make sure they were drilling enough for themselves. And this meant that the large transnational oil companies, like most of whom are owned by European or United States still, things like ExxonMobil, BP, British Petroleum, they don't dictate the price of the oil. OPEC does. So OPEC controls our international oil prices, which is why, like, even if we increase the amount of drilling in the United States, the price of oil doesn't always change as much as you would predict. And that's because global oil prices are set by OPEC. And this shows you here how many barrels are produced and used per day. So we're producing less than we're using. And if you're producing less than you're using, eventually you're going to run out. And that's kind of the problem we have with fossil fuels, aside from the environmental problems, which we'll get into. In the U.S., beginning in the 1950s, we started to extract domestic petroleum, and it became more expensive than importing it from Southwest or Central Asia. So our imports increased 14% from 1954 to 2009. The increase in prices of oil set by OPEC during the 1970s and 80s contributed to the U.S. decreasing its reliance on OPEC by about half. And so we had a gas crisis in the 70s. We had oil prices spike after 9/11. And when we looked at the price that was adjusted for inflation, petroleum plummeted to its lowest levels in the 1990s. And when that increased again, that kind of played into that global recession. So oil prices decreased for a very long time. And when oil prices decrease, we stop looking for it in the U.S. because people think it's not profitable. When oil prices increase, then all of a sudden we have an increase in production. So I would say right now, our oil production has decreased again a bit because prices have fallen. When prices rise for oil, you'll see those oil fields opening back up.